6.2. Boyle's law, Charles's law, and pressure law. There are three properties of gases. Created in the early 17th century, the gas laws have been around to assist scientists in finding volumes, amount, pressures and temperature when coming to matters of gas. The gas laws consist of three primary laws, all of which will later combine into the general gas equation and ideal gas law. The three fundamental gas laws discover the relationship of V, volume, P, pressure, and T, temperature. The ideal gas law is the combination of the three simple gas laws. The gases law that we will cover for this chapter including Boyle's law, Charles's law, pressure law or Gay-Lussac law. First is Boyle's law, also referred to as the Boyle-Mariotte law, is an experimental gas law that describes how the pressure of a gas tends to increase as the volume of the container decreases. Boyle's law's definition is the volume of a gas is inversely proportional to the absolute pressure applied to it when the temperature is kept constant. The law tells us that the volume of gas increases as the pressure decreases. Boyle's law holds true only if the number of molecules, N, and the temperature, T, are both constant. Boyle's law is used to predict the result of introducing a change in volume and pressure only, and only to the initial state of a fixed quantity of gas. History and derivation of Boyle's law. The law was named after chemist and physicist Robert Boyle, who published the original law in 1662. Boyle showed that the volume of air trapped by a liquid in the closed short limb of a J-shaped tube decreased in exact proportion to the pressure produced by the liquid in the long part of the tube. An animation showing the relationship between pressure and volume when mass and temperature are held constant. Boyle. However, if we plot pressure against 1 over volume, we can get a linear, straight line graph. From the graph, we can conclude that volume of gas is inversely proportional to the pressure of the gas. Thus the relationship for Boyle's law can be expressed as follows: P1V1 equals P2V2, where P1 and V1 are the initial pressure and volume values, and P2 and V2 are the values of the pressure and volume of the gas after change. Secondly is Charles' law. Charles' law, also known as the law of volumes, is an experimental gas law that describes how gases tend to expand when heated. Charles' law definition: the volume of a given amount of gas is directly proportional to the absolute temperature, Kelvin, when the pressure is kept constant. This relationship, the volume, is of direct proportion to the temperature. The volume will be increased as the temperature increase. V over T is constant. Thus V1 over T1 equals V2 over T2. V is the volume of the gas. T is the temperature of the gas measured in kelvins. The law was named after scientist Jacques Charles, who formulated the original law in his unpublished work from the 1780s. On the right is an animation demonstrating the relationship between volume and temperature. Charles's law, graph of V versus T. Charles's law. Charles's law, the volume of a given amount of gas is directly proportional to the absolute temperature, Kelvin, when the pressure is kept constant. V over T equal to constant, thus V1 over T1 equals V2 over T2. The absolute zero is the temperature where the volume becomes zero equals minus 273.15 degrees Celsius or 0 K, refer figure, where absolute temperature, T, K, equals T, degree C, plus 273.15. The equation shows that, as absolute temperature increases, the volume of the gas also increases in proportion. When using and dealing with this three gas laws and also ideal gas law, checkmark the temperature, T must in Kelvin, K. Checkmark the pressure must always be absolute pressure, in Pascal, not gauge pressure. T, K, equals T, 0 C, plus 273.15. Third law is pressure law. Or Gay-Lussac law. Gay-Lussac law states that the absolute pressure of a given amount of gas is directly proportional to the absolute temperature of the gas when the volume is kept constant. These laws are also known variously as the pressure law. Mathematically, it can be written as P pressure over T temperature equals K. Thus P1 over T1 equals P2 over T2. The law of combining volumes states that when gases react together they do so in volume which bears simple whole number ratio provided that the temperature and pressure of the reacting gases and their products remain constant. Thus, we had covered the three fundamental gas laws: relationship of pressure, temperature, volume and amount of gas. Boyle's law tells us that the volume of gas increases as the pressure decreases. Charles' law tells us that the volume of gas increases as the temperature increases. And pressure law, or Gay-Lussac law, tell us that the volume of gas increases as the amount of gas increases. The ideal gas law is the combination of the three simple gas laws. Questions. You can try to answer by using the concept of gas law. Questions 1. A sample of chlorine gas occupies a volume of 946 milliliters at a pressure of 726 pascals. What is the pressure of the gas, in par, if the volume is reduced at constant temperature to 154 milliliters? Answer: 4,460 pascals. Questions 2. A sample of carbon monoxide gas occupies 3.20 L at 125 C. At what temperature will the gas occupy a volume of 1.54 L if the pressure remains constant? Answer: 192 K. Questions 3. A gas has a pressure at 2.0 atmospheres at 18 degrees Celsius. What is the new pressure when the temperature is 62 degrees Celsius? Answer: 2.3 atmospheres. Here are the solutions of the questions. You can check your answer and your solution. If anything problems, don't hesitate to contact your lecturers to answer that questions. After read the question carefully. From the information given, you have to identify the correct laws, and you have to take out their formula. Absolute temperature and ideal gas law. Absolute temperature, refer to the figure. By extrapolating graph Charles's law, the volume becomes zero at 273.150 C. This temperature is called absolute zero. Absolute zero equals 273.150 C equals 0 K. Absolute temperature, also called thermodynamic temperature, is the temperature of an object on a scale where 0 is taken as absolute zero. Absolute temperature scales are Kelvin, degree units Celsius, and Rankine, degree units Fahrenheit. Absolute zero is the temperature at which a system is in the state of lowest possible minimum energy. As molecules approach this temperature, their movements drop towards zero. It is the lowest temperature a gas thermometer can measure. No electronic devices work at this temperature. The kinetic energy of the molecules becomes negligible or zero. Common temperatures in the absolute scale are 0 degrees Celsius, freezing point of water, equals 273.15 K. 25 degrees Celsius, room temperature, equals 298.15 K. 100 degrees Celsius, boiling point of water, equals 373.15 K. 0 K, absolute zero, equals 273